Hi friends, good morning. Welcome to my channel BALUMASTER. Today I am going to discuss the most important series that is JEE Mains and Advance. So the most expected questions or models in 2026. So most of the students selection, the chapter is matrices and determinants, and also this chapter you can able to score very easily in JEE Mains and Advanced. From matrices chapter, JEE Mains and Advanced questions how to crack. Today I'm going to discuss. This is what part 1. Afterwards I'll continue the part 2 and part 3. So look at an easy formula. If you know this formula, then you can able to score 4 marks very easily in JEE Mains, friends. The formula is determinant of adjoint A. Determinant of adjoint A is equals to the formula determinant of A whole power n minus 1. This is the formula. Determinant of adjoint A equal to det A power n minus 1, where n is order of a matrix. Where n is order of a matrix. So based on this concept, the questions they're going to ask in, usually every year they're going to ask, of course in 2026 also, based on this model questions, definitely they will ask friends. So not only determinant of adjoint A, we need to extend the formula. In determinant of adjoint A is equals to det A power n minus 1, where n is the order of the matrix. For example, order of a matrix is 3 by 3 means det A power 3 minus 1, det A whole square is your answer. For example, order of a matrix is 4 by 4 means det A whole power 4 minus 1, that is nothing but det A whole cube. So similarly, you are going to learn one more formula, that is determinant of adjoint A. This is equals to det A power, the formula is n minus 1 whole square. Same, n is the order of the matrix. So det A power n minus 1 whole square. So very simple formula, friends. Adjoints. How many adjoints are there? That power will be there here. How many adjoints are there? That power will be there here. So that's what we can able to write determinant of adjoint A. So here there are 3 adjoints. So then you can able to create the formula det A power n minus 1 whole cube. Same, n is the order of the matrix, right? So this is the very easiest formation. Like you can able to extend anything else in the question. May they can ask determinant of adjoint of so on adjoint A. They're going to give like 10 times. 10 times they give. By the time the formula is det A whole power n minus 1 whole power 10. For example, n is a 2 by 2 matrix, means 2 minus 1. 1 power anything 1, so det A is your answer. If they mention as det A answer, you are going to substitute the value. So this is very easiest formula. By using this formula, how they are going to ask in 2026, they are going to create a question. So based on the previous entrance examination questions, we can guess very easily based on this question 100% they are going to give a question in upcoming examination 2026, friends. Can we solve some now? This is the question, friends. Let A be a 3 by 3 matrix such that determinant of adjoint A is equals to 81. If S is equals to set of all n belongs to set of all integers z, determinant of adjoint A whole power n minus 1 whole square by 2 is equals to det A power 3n square minus 5n minus 4, then sigma n belongs to S, determinant of A power n square plus 1 equal to dash. Kind of questions are very easy by using previous formula which I discussed, friends. So here they are given 2 hints actually. So one hint is determinant of adjoint is 81 given. One more hint is S given. So how many unknowns are there? Look at carefully. Sigma n belongs to S. So S we are going to simplify by using this. Okay, that S is nothing but n values. By simplifying this one, you are going to get n values, one unknown, and determinant of A power something n can be written as det A power n. So determinant of A value also required. That's what this hint is also given. As per our formula, determinant of adjoint A can be written as det A power n minus 1 whole square. N minus 1 whole square whole power n minus 1 whole square by 2 is equals to det A power this total 3n square minus 5n minus 4. Now this n is different, friend. Why? Because this is n is order of the matrix as per I discussed. What is the order of the matrix? This is the 3 by 3 matrix. So 3 minus 1, 2 square means 4. So det A power 4 into n minus 1 whole square by 2 to do the cancel. So this is equals to det A power 3n square minus 5n minus 4. So this can be written as det A power 2 into n square plus 1 minus 2n by expansion of A minus B whole square is equals to det A power 3n square minus 5n minus 4. Now bases, both the bases are equal, so that's what powers also should be equate. So then what we are going to write after multiplication, 2n square plus 2 minus 4n is equals to 3n square minus 5n minus 4. Then after simplification, this is n square, then this is minus n, this is minus 6 equal to 0. Then n square minus 3n plus 2n minus 6 equal to 0. n into n minus 3 plus 2 times of n minus 3 equal to 0. And hence n minus 3 if you take common, n plus 2 equal to 0, then n values will become 3 comma minus 2. There are 2 values you are getting for n. This is first hint. Let us move to the second hint. Determinant of adjoint A whole power 81. This can be written as. So as per our discussion, this can be written as det A power n minus 1 whole cube is equals to 81. So determinant of a whole power n is nothing but 3 by 3 matrix, 3 minus 1, 2 cube, 8 is equals to 81. One can be written as 3 to the power of 4. Now this can be written as det a power 8 is equals to 3 power 4, and hence det a can be written as 3 power 4 whole power 1 by 8. It is nothing but 3 power 1 by 2, that is nothing but root 3. So determinant of value right, and n value also right here. This can be written as sigma n belongs to s, means n values are 1 is 3, one more value is minus 2. Determinant of a power n square plus n can be written as det a power n square plus n, because determinant of a power n can be written as det a power n, friends. According to this formula, we are going to write this value. So this can be written as determinant of a is fixed, that is root 3, but n value will vary. So root 3 whole power, substitute 3 here, 3 square plus 3 plus, because sigma means addition, that is plus, minus determinant of a root 3 whole power minus 2 whole square minus 2. Minus 2 whole square, n value is minus 2, right? That's what. So then as root 3 whole power, 3 square 9, 9 plus 3, 12, plus root 3 whole to the power of 4 minus 2 is nothing but 2. Root 3 whole power means 3 power 6, this is root 3 whole square means this is 3. The 3 power 6 value is 729 plus 3, that is nothing but 732, friends. This is your answer. So this model is very easy by knowing the small formula, that is determinant of adjoint A equal to det A power n minus 1. So we'll solve one more question. If you know another two formulas, then you can able to extend the topic and you can able to do more critical questions very easily, friends. The next concept is, for example, you have determinant of Ka is there. Determinant of Ka is there means the formula is K to the power of n into det A, friends. K power n into det A. You are not supposed to write K into det A. Usually, everyone will write K constant, keep it outside into det A. This is completely wrong formula. So, you are going to write K power n into determinant of A, where n is order of a matrix. Order of a matrix. For example, is a 3 by 3 matrix, and they are asking determinant of 5A. And they are given as det A value is something like that 2. So A is a 3 by 3 matrix given and det A equal to 2 given. They are asking determinant of 5A. So you are not supposed to write this is 5 into det A. That is completely wrong. You are going to write, if you want to take this constant out, means you are going to apply this formula 5 power n. N is order of the matrix, that is 3 into det A. Then 5 cube is nothing but 125 into determinant of A value how much? 2. That is nothing but 250 is your answer, friends. So that's all. It's a very simple formula. And coming to next formula you are going to apply, that is determinant of AB is there. If you are going to face any other determinant of AB, the formula is very simple. That is what? Det A into det B. That's all. So this is constant to matrix. That's what we are applying this formula. Whereas here A and B both are matrices. So whenever both are matrices, so that time you are going to write individual determinants. That is the formula, friends. If you know, along with the previous concept, if you understand these two concepts, then next level of JEE questions also you can solve very easily. The next question is, let A be a matrix of order 3 by 3 and the determinant of A is equals to given as 5. Det A is equals to 5 given. And if determinant of 2 adjoint of 3A into adjoint of 2A is equal to 2 power alpha, 3 power beta, 5 power gamma. Alpha, beta, gamma, all which is natural numbers, then alpha plus beta plus gamma equal to dash. This is the question. So let's solve this question, friends. So this determinant of 2 adjoint of 3A into adjoint of 2A is equals to, we are going to prove 2 power alpha, 3 power beta, 5 power gamma. Let us try to simplify that one. So then, if you feel, whenever determinant is there, some constant is there, that's what, let it be called this total value, let it be called A. This total value, let it be called A, friends. Now, it is of the form, as per our discussion, determinant of Ka format. Determinant of Ka can be written as K power n into det A, where n is order of the matrix. Now, in place of K, what value is there? 2. So, this can be written as 2 power n. N is what? Order of the matrix is 3. 2 cube into det A. Det A means determinant of this quantity. Determinant of adjoint of 3A into adjoint of 2A. This can be written as 2 cube. Already, this is coming in terms of 2 cube format. That's what, don't write 2 cube as 8. Keep like that only. So, 2 cube into. Now, again, let it be called this adjoint inside value, let it be called some A. Now, which formula? As we discussed in the previous formula, determinant of adjoint A. What is the formula of determinant of adjoint A? Det A power n minus 1. So, now this can be written as determinant of adjoint of A. This is. So, det A. Det A means this is A. So, 3A into adjoint of 2A whole power n minus 1. N is what? 3. 3 minus 1 is nothing but 2. Now, what to do? So, 2 cube. Don't take this 3 outside or 3 square. Again, you need to apply formula. Let it be called this total part as A. If you call that part as A, you are getting determinant of again K into A, this format. So what we can able to write, K power n means 3 power n. N is nothing but 3 into det A. Det A means determinant of A into adjoint of 2A. Square is there, don't forget whole square. Understand? Look at carefully. This can be written as 2 cube. Don't simplify. This is 3 cube format. 3 cube whole square. 3 power 6 into. This can be written as determinant of a into adjoint of 2a whole square. So this can be written as 2 cube into 3 power 6 into. Coming to here. Now it is of the form. A is a matrix. Adjoint to a is also matrix. Let it be called something like that b. Now it is of the form. This is matrix. This is matrix. So what we can able to write? Determinant of AB. Determinant of AB can be written as det A into det B. Then this can be written as det A into det B. Det B means adjoint of 2a. Don't stop here. Whole square is there. Square and square. Clear? So 2 cube 3 power 6 det A whole square. Det A is equal but 5 square into determinant of adjoint A. Again, determinant of adjoint A means the formula is det A 2a whole power n minus 1 3 minus 1 2. This one more square is there, right? Whole square. I hope you understood clearly. So 2 cube 3 power 6 5 square. Determinant of 2a whole to the power of 4. Then this can be written as 2 cube 3 power 6 into 5 square. Now determinant of again k. You don't have rights to take this 2 outside. Compulsory apply the formula then take it outside. What is the formula? Determinant of k. K power n. 2 power n. N is 3. Det a whole power 4. Don't forget this 4. Now this can be 2 cube into 3 power 6 into 5 square. 2 cube whole power 4 can be written as 2 to the power of 12 into det a whole to the power of 4. Now this is 2 power 3, 2 power 12. Bases are equal, powers are added. We are getting 2 power 15, 3 power 6 into 5 square. The determinant of a, which is given in the question, 5. This is 5 to the power of 4. Now this is nothing but 2 to the power of 15 into 3 power 6 into 5 to the power of. Bases are equal, powers are added. This is 6. This result is given in the question 2 power alpha, 3 power beta into 5 power gamma. If you compare these two values, you are getting alpha is equals to 15, beta is equals to 6 and gamma is also 6. Now the question is alpha plus beta plus gamma they are asking. So alpha plus beta plus gamma is equals to 15 plus 6 plus 6. 15 plus 12, this is nothing but 27. This is your no. By using the same concept, the same formulas by applying, we can able to solve more number of questions. I'm going to solve this question. Look at carefully. So let A be a non-singular matrix, means det A which is not equals to 0 of order 3. If determinant of 3 adjoint of 2 adjoint of det A into A is equals to something given, and determinant of 3 adjoint of 2a is given 2 power n 3 power n. Then they are asking modulus of 3m plus 2m. Means m and 2 values you are going to simplify. Then substitute, you get the answer. To 2 unknowns, they are given 2 equations. If you solve those 2 equations, you will be getting. The first equation is the determinant of this quantity is given. So let us try to solve. So let us write down the notation. Determinant in the sense you need to use the symbol as det. Det of. So what is that? 3 adjoint a. Adjoint of 2 adjoint of. Determinant of here it means det a into a. So I am writing in terms of symbols, symbolic. This is equals to, that result is 3 power 2 power something is given. I want to try to simplify this one. Afterwards, I will equate it. So this can be written as what? You are going to simplify this one by taking this part as a, as we discussed previously. So this is of the form what? Determinant of k. Determinant of k is nothing but k power n into det a. So k power n, 3 power, what is n? Order 3 into det a. Det a means determinant of adjoint of 2 adjoint of det a into a. Hope clear? This is equals to 3 cube as usual. Now adjoint of this one. Let it be called this adjoint of the total thing is let it be called a. So what is the formula? As we discussed already, determinant of adjoint a can be written as det a power n minus 1. So this can be written as det a. What is the value of in place of a? Determinant of 2 adjoint of det a into a whole power n minus 1. 3 minus 1 2. 3 cube into. So now what is the next step? 2. We can't take it outside. So we are going to simplify by applying the formula only. We can take out 2 outside. So how? Let it be called this total part as a. Again, this is of the form determinant of 2a. Determinant of k power n. So 2 power n. N is nothing but 3 into determinant of a. Determinant of adjoint of det a into a. This inside value. Whole square is there. Don't forget to write this one. Whole square. This is square. Now 3 cube. 2 cube whole square can be written as 2 power 6. This can be written as determinant of adjoint of det a into a whole square. Now 3 power 6, 3 as usual, 2 power 6 as usual. So now this is nothing but what again? Let it be called a. Determinant of adjoint a, det a power means determinant of det a into a power n minus 1, 3 minus 1, 2 whole to this square, this square. So this can be written as 3 cube 2 power 6 into square whole square means this is power 4. So determinant of det a into a whole to the power of 4. This part is very, very important. Look at carefully. So determinant of det A whole power 4. So this is what determinant of A is nothing but A matrix determinant. It is a non-singular matrix is given, that is mandatory, which is not equals to 0, don't worry. So if you simplify determinant for any matrix, it gives a constant. So it is nothing but constant into A. So whenever you treat it as constant, K into A format. So this is nothing but K power n into A. So this can be written as 3 power 3, 2 power 6, K power n. N is how much? 3 into det A. Isn't it? Power 4 is the right? Whole to the power of 4. This step is most important. Now this can be written as 3 cube into 2 power 6 into det A cube, det A power 4, whole power 4, det A power 16. Det A power 16, det A value is given? No. So det A power 16. Okay. Now this value is equal to what it is given? 3 power minus 13 into 2 to the power of minus 10. Now from this determinant of A whole power 16, I am going to write. From this det A whole power 16 is equals to, what shall I write? 3 power minus 13 into 2 power minus 10 whole by 3 power 3, 2 power 6. 3 power 3, 2 power 6. This can be written as 3 power 3, keep it upside, 3 power minus 16 into 2 power minus 10 no minus 6 becomes minus 16. So det A power 16 is equals to 3 power minus 16, 2 power minus 16. So what we can able to write from that? Determinant of A is equals to 3 into 2, 6 power minus 16. So from this determinant of A equal to how much? 6 to the power of minus 1, and hence it is 1 by 6. Det A value how much? 1 by 6. Now you are going to use the second result. What is the second result? Now let us simplify the second result. Determinant of A. So symbolic determinant of 3 adjoint of 2A is equals to 2 power n, 3 power n given. I will equate later. This can be written as same as usual method. 3 into let it be called A. So determinant of Ka can be written as K power n. N is 3 into det A. Det A means adjoint of 2A. Then what to do? Adjoint of 2A, right? 2A can be written as A. Now this can be written as 3 cube into determinant of adjoint A. Det A power n minus 1. N minus 1 is nothing but 2. Now 3 cube into, so what is the formula? Determinant of Ka again? K cube into det A. Don't forget to write this whole square. 3 cube into 2 cube whole square can be written as 2 power 6 into det A whole square. Now 3 cube into 2 power 6 into already determinant of A value, just we find 1 by 6. 1 by 6 can be written as 1 by 6 square, that is nothing but 6 into 6. Now this can be written as 3 cube into 2 power 6 into 1 by 3 into 2 into 3 into 2. 3 square will be cancelled, 1 3 will be remaining, 2 square will be cancelled, 4 will be remaining. So this can be written as 3 into 2 to the power of 4. So 3 power 1 into 2 to the power of 4. This is equal to what? 2 power n, 3 power n. So this can be written as what? 3 power n into 2 power m. Then what we can able to write from this information? From this information what we can able to write? M is equals to 4. N is equals to 1. So then substitute in this modulus of 3m plus 2n can be written as modulus of 3 into 4 plus 2 into 1. This is modulus of 12 plus 2, that is 14. Under mod, the answer is 14. 14 is your answer, friends. So these kind of questions undoubtedly, which is very, very easy, very, very important, look like very difficult questions, but if you try to solve by those three conditions, it is very, very easy, friends. Next question is, let A and B be two square matrices of order 3 such that det A is equals to 3, det B equal to 2. Then they are asking determinant of A transpose A adjoint of 2A whole inverse into adjoint of 4B adjoint of AB whole inverse into A transpose is equals to dash. Look like it's a very lengthy problem and big problem and difficult problem, but by knowing those three conditions, it is very, very easy. Now what is the case? How you are going to evaluate this total function? How you are going to evaluate, So determinant is there. Different matrices are there. See once, A transpose is a matrix. A is a matrix. This is also a matrix, and this is matrix. This is matrix. This is matrix. This is also matrix. So you have a usual formula. Determinant of AB can be written as individual determinants. Det A into det B. That's all. Determinant of A, B, C is there means very simple. Det A, det B, det C. That's all. Like how many number of matrices are there in a single determinant, we can able to split into individual determinants. Now this can be written as, so determinant of A transpose, determinant of A into determinant of, this is what? Adjoint of 2A whole inverse, determinant of adjoint of 4B, determinant of adjoint of AB whole inverse into determinant of A into determinant of A transpose. Okay, now to continue this sum, you have to know two more important points. What are the important points means? The determinant of A and the determinant of A transpose, both are same. If you take any example, A matrix, A transpose matrix, if you find out determinants, both will be equal always. And moreover, determinant of A inverse is always can be written as det A power minus 1. The other property is determinant of A inverse equal to det A power minus 1. Of course, this can be written as 1 by det A. So by applying these formulas, how the problem will change? Means determinant of A transpose can be written as det A. Of course, det A is nothing but det A only. This can be written as determinant of adjoint of 2A whole inverse, and hence what we can able to write by determinant of adjoint of 2A. Clear? Into this doesn't change as usual, adjoint of 4B. According to this format, this will be adjoint of AB into det A. Of course, determinant of A transpose is nothing but det A. Now, which values you know? Det A, det A, det A, det A, det A power 4. Of course, det A result is given as 3. So this is nothing but what? 3 to the power of 4 into what shall I write? The remaining simplification. Very simple. Let it be called this is A. Determinant of adjoint A. As you know the result. Determinant of adjoint A is equals to what? Det A power n minus 1. Right? So now this is nothing but determinant of 4B power n minus 1. 3 minus 1 is 3. 2. Because the order is 3. Whole by determinant of adjoint of 2A. Let it be called this is A again. Determinant of adjoint A can be written as det A power A means 2A. N minus 1, that is 2. And this can be written as determinant of adjoint of 2B, AB. This can be written as, this is also A. Determinant of AB whole power 3 minus 1, 2. So the total problem reduced to like this. Let us simplify. So 3 to the power of 4. Same, your known formula. Determinant of K, 4 is constant, right? Which formula? Determinant of K is equals to K power n into det A, right? So then what we can able to write? 3 power 4 into, so K power n, 3 power 3 into det B. Don't forget to write this whole square. Whole by determinant of 2A. The same formula, 2 cube into det A whole square into determinant of AB can be written as det A into det B whole square. Now this can be written as 3 to the power of 4. 4 cube whole square, 4 power 6 into determinant of B whole square by 2 cube whole square means 2 power 6 det A whole square into det A whole square into det B whole square. What to do? 3 power 4. This is 2 square whole power 6, that is nothing but 2 power 12. Det B is nothing but 2, 2 power 2 whole by 2 power 6 into det A whole square, det A whole square, det A, determinant of A equal to 3, 3 square into 3 square, 3 to the power of 4 into determinant of B is 2, 2 square. Now, after cancellation, 2 square cancel, 3 power 4, 3 power 4 cancel, then it remains 2 to the power of 6, that is 64. 64 is your answer, friends. So, friends, this is the logic. So by using this concept, this kind of sums are very easy, very important. This is the most expected area in matrices and determinants in part 1, friends. If you like this video, if you enjoy this video, let us comment as part 2, then I will release part 2 also, friends. So that's all for today's class, friends. Thank you so much, friends. Thanks a lot.